Hello, everyone. My name is Vanessa Lieberman, and I am the Department Safety Coordinator for both the Viticulture, Enology, and Food Science departments. Today, we're going to talk about laboratory safety and explain what all of the acronyms on the screen mean. There's a lot of information in this presentation, so please bear with me, and I appreciate your attention and patience. Let's start off with some general lab safety notes. Don't eat, drink, chew gum, or apply cosmetics in the lab. These are areas where chemicals or biological hazards are used and could cause accidental contamination. Don't store food in laboratory refrigerators. These fridges can contain chemicals and other hazardous material that can contaminate your food. Don't leave equipment or reactions running unattended. This could lead to unwanted accidents. Don't leave your lab a mess. Each lab should be clean, organized, and free of clutter. All chemicals and solutions should be properly labeled and stored. A clean and organized lab helps prevent accidents. These are the main topics that we will discuss today. The Injury and Illness Prevention Plan, or IIPP, which is filled out and provided to employees and students by the department. The Chemical Hygiene Plan, which is in the Campus Distributed Laboratory Safety Manual. Lab Hazard Assessment Tool, or LHAT, and Standard Operating Procedures, which are lab-specific and completed by and distributed by the PI. Training, such as the UC safety training called the UC Fundamentals of Laboratory Safety, and site-specific training, which is done by the PIs or lab managers in each laboratory. And the chemical inventory system, which uses the online tool called Chemicals. We also discuss safety data sheets, or SDS, how to read them, and the global harmonized system of labeling hazards. Personal protective equipment, which is provided by the PI. The emergency action plan, which is provided by and specific to the department, and handling and disposal of hazardous materials in accordance with the laboratory standard or the hazard communication standard. The Safety Services website contains many resources for all of these topics. The Injury and Illness Prevention Plan, or IIPP, details management commitment and assignment of responsibilities for those maintaining and implementing the plan. It discusses various safety communication systems with employees. The IIPP outlines a system for assuring employee compliance with safe work practices, as well as scheduled inspections and evaluation systems. It also contains procedures for correcting unsafe or unhealthy conditions, safety and health training and instructions, record keeping and documentation, and accident investigation procedures. We will now discuss some elements of the IIPP. One of the elements of the IIPP is the Chemical Hygiene Plan. This can be found in the UC Davis Laboratory Safety Manual. The Chemical Hygiene Plan establishes a formal written program for managing the risks posed by health and safety hazards associated with the use of hazardous chemicals in laboratories. It describes proper use, handling, storage, and disposal practices and procedures to be followed. This plan applies to employees who use chemicals in teaching and research laboratories at the UC Davis campus. It is the responsibility of the employer to provide a workplace free from recognized hazards that may cause death or serious injury. It is the responsibility of the employee to comply with occupational safety and health standards, rules, regulations, and orders. The Chemical Hygiene Plan also details the rights and responsibilities of each of the following parties as determined by the UC Office of President and the Board of Regents. Campus administration policies and procedures are the responsibility of the Chancellor, Provost, and Dean's offices. Policy specifics is the responsibility of the Chemical and Laboratory Safety Committee. PI support and enforcement is the responsibility of the department chair. Site-specific rules, training, and laboratory safety procedures are the responsibility of the PI. Personnel are responsible for taking the training, understanding standard operating procedures, reading safety data sheets of chemicals used in the lab, and wearing personal protective equipment. Safety information, training tools, support, and inspections are the responsibility of the campus environmental health and safety team. Again, this plan with detailed information can be found in the Laboratory Safety Manual. There are multiple online tools through which training and safety documentation is managed. All of these tools can be found on the ehs.ucop.edu website. This is what the homepage looks like. If you click on the More Apps button, you will see all the options of the online safety tools. This main page is the workspace page where you will find the Lab Hazard Assessment Tool, or the LHAT. The LHAT details the hazards present in the laboratory and communicates these hazards to employees. This will be different for each lab, as each lab will have potentially different hazards, such as chemical, biological, physical, or otherwise. Personnel working in the lab must be given access to their lab's LHAT. Once you have read through it, a notification will be sent to the PI or lab manager letting them know that you have completed reviewing the LHAT, and you will be notified about what personal protective equipment or PPE you will need for working in the laboratory. Because working in the laboratory presents many various hazards, safety training must be completed prior to beginning any work in the lab. Personnel working in laboratories must complete the online UC's Laboratory Safety Fundamentals, complete the site-specific training, and complete any additional training as required by the lab which you will be working in. This additional training will be discussed later on. You must also review the LHAT and watch the video on how to properly use PPE, obtain the PPE required for your lab, and receive training for all laboratory standard operating procedures, including procedures that require prior approval. You must also read and understand the IIPP, the Emergency Action Plan, and the Chemical Hygiene Plan. UC Laboratory Safety Fundamentals is an online course which must be completed by all laboratory personnel before given access to the laboratory. It is an introduction to laboratory safety fundamentals, chemical safety, and general safety. It covers relevant information discussed in the UC Laboratory Safety Manual and rights and responsibilities according to applicable regulations. Sorry, my slides are not cooperating. Site-specific training. This is an example of the site-specific training checklist. You will need to receive this training prior to beginning work in the laboratory. In this training, you will need to learn the location and proper use of safety equipment, such as personal protective equipment, fire alarms, safety eye washes, spill and first aid kits, chemical fume hoods, and biological safety cabinets. It will also review proper emergency response and ensure that you have read the department-specific emergency action and injury and illness prevention plans, in addition to laboratory-specific standard operating procedures. Here's an example of the training matrix. These will look different depending on the types of hazards present in the labs you'll be working in. Different hazards may require additional training. These are some examples of the different types of online training available. Everyone will need to take the research and laboratory safety training. Certain types of equipment used in labs may require additional training. Ergonomics training may be required if you are working on a computer for longer periods of time. If the lab you will be working on has any biohazardous organisms, you will need biological safety and possible medical waste training as well. So now we will discuss chemical use a bit more. Prior to buying any new chemicals, check your lab's inventory and make sure you don't already have it. Add each new chemical to the chemical inventory system and place a barcoded tag on the chemical. These are called chem tags. You have to enter the barcode manually into the chemical inventory system when you first enter the chemical. However, after that, you can use the barcoded scanner to scan the chemicals in your lab to log them into your inventory. Read the safety data sheet of the new chemical to determine the hazards. If it requires a standard operating procedure, add it to your lab's existing list or create a new one if necessary. Use proper personal protection. And finally, if you are disposing of the chemical or any waste, it must be disposed of properly and in a labeled and dated container. Safety Net 8 details guidelines of proper waste disposal. All chemicals and solutions, including water, must contain a label with a full chemical name and date and must be stored properly. Apologies for the slides skipping. Chemicals is the online tool for a lab's chemical inventory. It can be accessed through the ehs.ucop.edu site referenced earlier. The chemical inventory will show you the name, location, and hazards of each chemicals in the laboratory. We will now discuss chemical safety data sheets, or SDS. The SDS describes the name of the chemical, the hazardous nature of the chemical, physical characteristics, fire and explosion information, reactivity of the chemical, health hazard information such as health effects and symptoms, personal protective equipment needed when using the chemical, how to handle leaks, spills, and disposal, and any special precautions. Here's an example of an SDS. Each section describes the information discussed on the previous slide. In the SDS, you will also find the Globally Harmonized System of Classification and Labeling of Chemicals, or GHS. This labeling system uses a single word such as danger or warning and gives a precautionary statement indicating how to properly handle the product in order to minimize risks to the user. Hazards of chemicals are associated with an H code. H200s are physical hazards, H300s are health hazards, and H400s are environmental hazards. The lower the number within a category, the higher the hazard. So H300 is more hazardous than H304. These hazard codes are also associated with hazard symbols. You'll see these symbols on the chemical bottles. Each symbol depicts the hazards associated with the chemical. There are a number of hazardous material control systems to help mitigate the risk of exposure. These are known as engineering controls because they help to remove or contain the hazard if used properly. Examples of these are chemical fume hoods, glove boxes, flammable liquid storage cabinets, biological safety cabinets, and spill cleanup kits. Now let's get into SOPs and why they are important. Standard operating procedures, or SOPs, are known as administrative controls. The purpose of an SOP is to mitigate the risk of exposure of employees to any hazards present in the workplace. SOPs document the laboratory-specific procedures for safe handling, storage, and disposal of hazardous chemicals. PIs and laboratory supervisors are responsible for establishing SOPs relevant to health and safety for laboratory activities involving hazardous chemicals under their direction. Cal OSHA requires use of SOPs for work with hazardous chemicals. SOPs establish a designated work and storage area, determine engineering controls such as fume hoods or flammable cabinets, the proper personal protective equipment for working with certain chemicals, establish procedures for waste removal, and set up decontamination procedures. Here are examples of some of the hazard classes of various chemicals that require SOPs. This list is not exhaustive, and the list of all chemical hazard classes that require SOPs, as well as templates, can be found on the Safety Services website. You will need to read your lab-specific SOPs prior to using a chemical containing these specific hazards. Now we will discuss personal safety in the laboratory. Proper attire is required in order to work in a laboratory. Long pants or skirts and tops with full coverage must be worn. In other words, you must be covered from the shoulders down. Midriffs, bare shoulders, bare ankles, stockings, nylons, and leggings, or jeans with holes in them are not acceptable. You must also wear closed-toed and heeled shoes that fully covered your feet. Tying up long hair is also advised. Personal protective equipment, or PPE, are used to protect you from various hazards. Some examples of these are eye protection, such as safety glasses, goggles, or face shields, gloves, such as nitrile, chemical handling, and higher or low temperature gloves, protective clothing, such as lab coats and chemical aprons, respiratory protection, such as dust and mist respirators, and others, such as hearing protection. All PPE must be used properly in order to be effective. I would also like to discuss some PPE etiquette. Do not wear soil or contaminated lab coats in shared or public spaces. This is true for both chemical and biological contamination. Wear clean lab coats for use in autoclave rooms. Do not eat or drink in your lab coats. Unfortunately, I've seen too many people in these buildings do this. I know not many of you will be working with hazardous materials. This is still something that should be abided by for the same reason that you should not eat or drink in your lab. If you are transporting something to a different location in the building, your items must be stored in a clean secondary container. Do not use gloves in hallways. If you're transporting large amounts of liquids, use a clean cart to transport your items to avoid dropping and spilling. These items must still be stored in a clean secondary container. If you're working in another lab, have another lab coat in that lab or bring a clean lab coat with you. This is especially important for those working with biohazardous materials. Different labs may have different hazards, and you don't want to contaminate any lab with hazards that you're working with from a different lab. Remove gloves before putting on or taking off your lab coats. I have seen people touch biohazardous materials or chemicals with gloves. Remember that they need a lab coat and then put the lab coat on with those same gloves. Doing this contaminates the inside of your lab coat and therefore any part of you touching the lab coat. Change your gloves immediately if any chemical or biohazard is spilled on them. Gloves have breakthrough time for certain chemicals and have small holes unseen to the naked eye. And can have small holes unseen to the naked eye. 1 to 5 out of 80 gloves can have allowable defects. Do not touch your face, phone, headphones, or any exposed body part with gloves. Doing so can contaminate your skin or personal items with any of the hazards you have on your gloves. Wash your hands after you remove your lab coat. The idea is that your lab coat is contaminated, so once you touch it again, your hands are then contaminated. Washing your hands after removing your lab coat removes any hazard that was on your lab coat from your hands. This chart shows the compatibility of different glove types with a select few common hazardous chemicals used in labs. Most labs use nitrile gloves for use with hazardous chemicals, which is not always the best selection for chemicals displayed on this chart. Prior to starting work with any hazardous chemical, be sure you have the appropriate gloves in order to fully protect yourself from any exposure. You can find an expanded version of this chart by searching glove selection chart online. So next we will discuss the Emergency Action Plan, or EAP. The EAP must be in writing and include the following elements: emergency escape procedures and emergency escape route assignments, procedures to account for all employees after an emergency evacuation, preferred means of reporting fires and other emergencies, names or regular job titles of persons or departments who can be contacted for further information or explanation of duties under the plan, a system to notify employees of an emergency, procedures for employees who remain to complete critical operations before they evacuate, rescue and medical duties for those employees who are to perform them, and training for all employees on the EAP. The written plan must be kept in the workplace and be made available for employees to review. You should also be aware of the location of all the exits for your workplace and building, the alarm pull boxes and fire extinguishers, the nearest phone, safety showers and eye washes, first aid kits, and spill kits. These will be covered in your site-specific training. Also, if you will need assistance in the event of an evacuation to safely exit the building, please contact me so we can set up aid and training for emergency evacuations. Here's an example of a building evacuation map. These are posted at the entryway to each lab. This is the emergency evacuation map. This map is also located in the department EAP and at the entryway to each lab. It is simple, but details where to meet during an emergency evacuation of the complex. Members of the Food Science Technology Department will meet on the right-hand side of the parking garage if you are facing the parking garage. In the event of a fire, follow these procedures. If the fire is small, you may attempt to neutralize the threat without endangering yourself. If you are unsure, leave the area, being sure others are out. Close the door. Activate the nearest building fire alarm. Dial 911 from a landline or 530-752-1230 from a cell phone. Stay away from the area and close the door. Go to the agreed meeting place and stand by to advise emergency personnel when they arrive. So I want to talk a little bit about fire extinguishers. There are 5 different types of fire extinguishers. All buildings these are Class A, ordinary combustibles, wood, paper, and trash. Class B for flammable combustible liquids. Class C for electrical fires. Class D for special metals. And Class K for kitchen fires. All buildings in the RMI are equipped with combo fire extinguishers, which are a combination of Class A, B, and C. These emit a powder that suffocates the fire, and they need to be checked monthly. So how to check the fire extinguishers? Again, these need to be checked monthly. Make sure the needle is within the green range. Look at the needle as if you were looking at at a meniscus of liquid. Once you have checked it, put the date and the initials of the person checking on the tag. If there are any issues, contact fire prevention at ucdavis.edu. So how to use a fire extinguisher? The acronym PASS can be used to remember how to use a fire extinguisher properly. Hold the pin, aim at the base of the fire, and stand back 5 to 6 feet. Squeeze the handle and move carefully closer as the powder is being discharged. Sweep back and forth to cover the range of the fire. This should only be done when the fire is at the beginning stage. If flames are large, evacuate and call 911. 911 should have already been alerted once the fire started. Fire extinguishers only last 20 to 30 seconds. Here's also a link of how to properly use a fire extinguisher. This training video is a great video. For the sake of time, I will not play it now, but I highly recommend watching it for those who are interested. In the event of an earthquake, follow these procedures. Get under a desk, table, or archway during the shaking. Leave the building after the shaking is over. If you're outside during the shaking, stay clear of buildings, trees, or any structures. Dial 911 from the landline or 752-1230 to report any fires, ruptured pipes, or downed electric lines. Assist injured persons or securing medical attention. Go to the agreed meeting place and stand by to advise emergency personnel when they arrive. In the event of an active shooter, there are 3 immediate actions: run, hide, and fight. If you can't run, hide. If you can't hide, fight. During this type of emergency, seek help. Call 911 and provide as much information as possible, such as location, what is happening, description of suspect or suspects, your name and number. Silence your phone. If you can't speak, turn the sound on and leave the line open so that police can hear what is happening at the scene. More information can be found on the Safety Services website. I also highly recommend everyone take the online active shooter training offered on the LMS system. Here are some campus safety tips from the UC Davis Police Department. Always be alert to your surroundings. This includes persons and vehicles. Report any suspicious activity to the UC Davis Police Department at 530-754-2677. Do not allow strangers to enter your building behind you. Report any criminal activity such as break-ins, intruders, robbery, or assault immediately to 911. Always lock your doors and secure your property by locking doors to offices, laboratories, and buildings. At campus office facilities, report malfunctioning or broken doors and windows to facilities by calling 530-752-1655. Some department safety tips are: do not leave personal items or items of value in your vehicles and always lock your vehicle. Set up a communication system with other coworkers. If you're working late or alone, this can be used to alert of your safe arrival and departure from the building in the case of any emergencies. Make sure all entry doors are closed and not propped open to prevent building break-ins and theft. And report any building malfunctions to BFTV facilities at ucdavis.edu. Some campus resources for personal safety or property safety are the UC Davis Campus Emergency Line, which is 530-752-1230. This can be used for police, fire, or medical emergencies. If you're on a cell phone, use this number. If you're on a landline, you may dial 911. UC Davis Police Department 24-hour non-emergency number is 530-752-1727. They can be contacted to report suspicious behavior or for non-emergency situations. They can also be contacted if you are on campus and feel unsafe. The UC Davis Police Department also offers Safe Rides Escort Service. They can be contacted by calling 530-754-2677. Or you can look them up on their website at police.ucdavis.edu/saferides. Their hours of operation are 7 days a week from 5 p.m. to 10 p.m. if you're on campus and want to go to another on-campus location, or 7 days a week from 10 p.m. to 6 a.m. on campus to any location in the city of Davis. VIP wheelchair transportation is also offered by this service 24/7 on campus to another campus location. They also offer this 7 days a week from 10 p.m. to 6 a.m. from on campus to any location in the city of Davis. In addition to resources for laboratory safety, Safety Services also has resources for personal safety. Some of these resources are the campus emergency notification system called WarmMe. Make sure you are signed up for WarmMe to receive notifications and updates about emergencies happening on campus and in Davis. The Everbridge app is a personal safety app that can be used to quickly make emergency phone calls, set up emergency contacts, or to report suspicious activity. Translock is a relatively new app for the Safe Ride program in which you can arrange for a ride from the UC Davis Police Department. So now we will discuss laboratory accidents with a focus on chemical spills. So what causes laboratory accidents? Major contributors to laboratory accidents are rushing, frustration, fatigue, and complacency. Other contributors to errors or accidents are eyes not on the task, mind not on task, being caught in the line of fire, and loss of balance, traction, or grip. Let's focus on one of the most common lab accidents, a chemical spill. In the event of a chemical spill, follow these procedures. If 1 pint or more is spilled, or if you are not comfortable cleaning up the spill, call the UC Davis Fire Department or 911 from a landline. Evacuate the room, close the door, and wait for emergency personnel. If the spill was a flammable substance, turn off all ignition sources before securing the room. In case of chemical contact with skin or eyes, flood the affected area immediately with water and seek medical assistance. Remove all contaminated clothing. Do not be concerned with modesty in the event of a chemical spill. Some labs keep spare lab clothing for this purpose. Small spills may be cleaned up by lab personnel using spill kit. Any acids and bases should be absorbed and neutralized. Flammable liquids may be absorbed. Do not attempt to block cryogenic liquid spills with unprotected hands. In this case, allow the liquid to evaporate. Solid spills are not usually emergencies. If the spilled material is toxic, use dampened cloths, or paper towels to transfer it to plastic bags disposed of as hazardous waste. Also report spills to EHS at 530-752-1493. Safety showers and eye washes should be used if someone is contaminated with a hazardous chemical. Remove all contaminated clothing if possible. Rinse in the emergency showers for 15 minutes. If a splash occurred in the eyes, rinse the eyes in the eye wash for 15 minutes holding eyes open. Call 911 or 530-752-1230 or go to the hospital emergency room. Here is the chemical incident decision chart. Tools such as this can help determine if the spill can be handled by lab personnel or if emergency help is required. Here's an example of a chemical spill kit. Chemical spill kits contain neutralizers for acids and bases, absorbent materials for soaking out spills, brushes and dustpans for picking up used absorbent material, gloves, aprons, or other PPE. Safety Net 13 contains guidelines of how to clean up a chemical spill. Here are some steps for cleaning up chemical spills. Work from the outside in. Start containing the spill with a barrier of absorbent material to prevent further spread. Remove any physical hazards such as glass with tongs and place in a hard-walled container. Absorb any excess liquid using paper towels or other absorbent material. Double bag in plastic bags or single hard-walled plastic containers and dispose of as hazardous waste. So we talked about laboratory accidents, but what about near misses? These are important as well as they can help prevent an accident from happening in the future. Any incidents or concerns that may be reported to safety services. A form for this can be found in the department's IIPP. All faculty members, staff, students, and visitors at UC Davis can participate in making the campus a safe place to work, study, and live by identifying health and/or safety hazards or unsafe conditions by informing those responsible for the problem area. Employees are advised the use of this form or other reports of unsafe conditions or practices are protected by law. It would be illegal for the employer to take any action against an employee in reprisal for exercising rights to participate in communications involving safety. Now let's talk about hazardous waste. Here are some of the hazard classes and their definitions. Toxic substances are any substance which can be harmful to the environment or hazardous to your health if inhaled, ingested, or absorbed through the skin. This includes acute toxins, carcinogens, or other chronic toxins with bioaccumulative properties or persistence in the environment. Reactive substances are substances that can produce toxic gases or explosive, react violently with water, or contain cyanide or sulfide. This includes explosives, oxidizers, reducers, water-sensitive, acid-sensitive, and air-sensitive, and unstable chemicals. Flammable substances are substances that have a flash point of less than 140 degrees Fahrenheit are capable of causing fire through friction, moisture, or reactivity. This includes oxidizers and flammable compressed gases. Corrosive substances have a pH of less than or equal to 2 or greater than or equal to 12.5 and are corrosive to tissue or metals. Guidelines for disposal of chemical waste can be found in Safety Net 8. One of the online safety tools is the Waste Program. This tool creates a hazardous waste label and sets a timer on the waste for when it needs to be picked up. All hazardous material and hazardous chemical waste must be picked up by Environmental Health and Safety or EH&S approved contractor. Not many chemicals can go down the drain, and drain disposal of non-hazardous chemicals is strictly regulated. More information on this can be found in Safety Net 6. Here are some guidelines for disposal of hazardous waste. Always reduce the volume of hazardous chemicals and minimize the generation of waste. Only order and use what you need. Use the hazardous waste label supplied by Waste Online tool. For liquid waste, a screw cap leak-proof container must be used. Liquid waste bottles must also be stored in secondary containment. Segregate waste by hazard class. Proper chemical segregation is explained in the Stanford Segregation Guide, which I will talk about on a different slide. Waste must be picked up within 9 months of initial label date. Extremely hazardous chemicals must be picked up within 90 days. Triple rinse empty containers before disposal in the trash. Some containers that previously contained hazardous materials may need to be picked up by EH&S as well. Dispose of any sharps such as syringes, glass pipettes, and other sharp materials in a specially designated rigid sharps container. This is the online waste tool. Here you can create a waste tag for different types of waste. You can learn how to use this tool by going to Safety Services website and searching for waste tracking. This is the Stanford Compatible Storage Group Guide of how to properly store chemicals. Please refer to this guide when storing new chemicals or hazardous waste. Incompatible chemicals should not be stored together as they may cause harmful reactions leading to damage and injury. Here are some of the most frequently violated safety rules. Proper management of hazardous waste, proper labeling of hazardous solutions. All solutions, including water, must have a label with the full content spelled out in English and not in chemical formulas. The labels must also have the initials of the researcher responsible for the solution and date of preparation. Abbreviations may be used. However, if they are used, there must be a list posted in the lab that explains all of the abbreviations. Lab workers must wear proper protective clothing, the bare minimum being closed-toe and heeled shoes, long pants, or a long skirt. Lab coat or chemical apron and eye protection must be worn when working with any acids, bases, solvents, powders, or any pressurized or vacuum system. Lab workers must be trained on all safety equipment and standard operating procedures. And labs must be clean and without clutter, and no food or drink is allowed. That concludes my presentation. Thank you all for listening. I'm happy to answer any questions you might have. And please feel free to contact me with any questions or concerns that you might have related to safety. Thank you.